Okay, so this is 2025 Higher Level Maths Leaving Cert Paper 1, question 6a. Write down in descending powers of p the first three terms in the binomial expansion of 2p plus 3 to the power of 7. Give each term in its simplest form. For example, the first term should be of the form a p to the power of 7, where a is a constant. Okay, so we're going to start with 2p plus 3 to the power of 7. So normally the way you would do this is you can use Pascal's triangle, but I'm going to use, let's say 7, choose 0. And then I'm going to take the first term, which is 2p, got to raise that to the power of 7. The second term is there, but it's to the power of 0, which is just 1. So I'm going to leave that out. So then you go to 7, choose 1, and take the first term, 2p, raise that to the power of 6. Now the second term is there to the power of 1. Then the third term is 7, choose 2. Take the first term, 2p, now raised to the power of 5. 3 now goes up another power, so it's to the power of 2, and so on. So there are our first three terms. You just got to work those out. So if you do 7, choose 0, you get 1. If you do 2 to the power of 7, you get 128. And then you've got p to the power of 7 as well. Here you've got 7, choose 1, which is just 7. You've got 2 to the power of 6, which is 64. You've got p to the power of 6, and you've got that times 3 as well. 7, choose 2 is 21. 2 to the power of 5 is 32. You've got p to the power of 5, and then you've got 3 squared, which is 9. So we just need to simplify all of that. First term is straightforward enough. It's just 128 p to the power of 7. The second one, you got to multiply 7 by 64 by 3. That's 1344. And you've got p to the power of 6. Here you've got 21 times 32 times 9. That's 6048. And you've got your p to the power of 5 as well. And that goes on as well. So that's really it. That's the first three terms of that particular expansion. Okay, let's have a look at part B. H of x is the following function of h where m and r are positive constants and x is real. H of x is 6mx squared minus 4rx plus 54m. The equation h of x equal to 0 has exactly one solution. Use this to show that r is equal to 9m. Okay, so this is really just a case of writing down the discriminant and sticking in the various values. So we have a is equal to 6m, that's the coefficient of x squared. B is equal to minus 4r, that's the coefficient of x. And c is the term independent of x, which is 54m. Now, for our equation to have exactly one solution, b squared minus 4ac has to be equal to 0. So b squared is minus 4r, which we've got to square, minus 4 times a, which is 6m. C then is 54m, and that's equal to 0. So let's just multiply all this out. Well, minus 4r squared is going to be 16r squared. Now here we've got a minus times a plus times a plus. That's going to be minus. We've got to multiply 4 by 6 by 54. That's 1296. And then we've got m times m, which is m squared. That's equal to 0. Now, happily enough, everything here is divisible by 16. So if we divide the first term by 16, we get r squared. Divide 1296 by 16, you get 81, and that's m squared. That's equal to 0. Let's just bring that 81m squared over to the other side. So that's 81m squared here. Now, what we got to do here is square root both sides. So if we square root the left-hand side, we get r. Square root the right-hand side, you get plus or minus 9m. Now, we have to show that r is equal to plus 9m. So what we know here is that it says that m and r are positive constants. M and r are both positive constants. So or cannot be equal to minus 9m, because minus 9m would be a negative constant, if you like. Because remember, m is positive, minus 9 is negative. That would give us a negative number. We can say, kind of, since or and m are positive, that must mean then that or is equal to plus 9m. And that's really it. Okay, so let's look at part 2. Use the fact that or is equal to 9m to find the value of this solution. Okay, so we know that or is equal to 9m. Now we also know that a is equal to 6m, b is equal to minus 4or, and c is equal to 54m. So I'm just going to use the quadratic formula to work out the solution. So we know that x is equal to minus b, so that would be plus 4or, plus or minus the square root of b squared, so that's minus 4or squared, minus 4 times a, which is 6m, times c, which is 54m. All of this is over twice a, which is 6m. Now let's just multiply some of this out. So we have 4or plus or minus the square root of 16or squared minus 1296, and that's m squared. So you multiply 4 by 6 by 54 gives 1296, and m times m is m squared. Underneath then we've got 2 6's, which is 12m. Now we're kind of stuck at this stage, so what I'm going to do is substitute this in at this stage. So or is equal to 9m. So we've got 4 times 9m plus or minus the square root of 16 times or squared. So that's 9m, which you've got to square, minus 1296m squared. So all of that is over 12m. Now you kind of got to realize here as well that everything underneath the square root should become 0. So let's see, does it? So we've got 4 9s 36m plus or minus the square root of, well, if you square 9 you get 81, and multiply 81 by 16 you do get 1296m squared minus 1296m squared. So you can see that we do get 0 underneath the square root. So you got 12m here. Okay, so we've got 36m plus or minus the square root of 0, so I'll just leave that out, divided by 12m. The m's here will cancel, and we've got 12 into 36, which is 3. So our solution is x is equal to 3. Okay, so that's it for this question.